going to look at chapter 2.3 and 2.4, which is proving theorems and special pairs of angles. This first part is section 2.3, which you can follow along on page 43 of your textbook if you'd like. So we're going to be looking at more proofs. And I want to just quickly remind you, I think I mentioned it in the last video, but we have a variety of reasons that can be used in proofs. First of all, given information can be used, definitions, postulates, properties of algebra, and theorems. And I will be providing you guys with a list of all these things if I have not already. So first theorem we're going to talk about for today is called the midpoint theorem. So we talked about midpoints last chapter. Remember, a point takes a segment and it splits it into two congruent segments, right? If a point is a midpoint, then it divides a segment into two congruent segments. So the midpoint theorem is kind of similar. It says if point M is the midpoint of segment AB, then the measure of segment AM equals 1/2 the measure of AB, and the measure of MB equals 1/2 the measure of segment AB. So if you think about it, if it's dividing it into two congruent parts, right, each part is a half. So that should make reasonable sense. But we're going to go ahead and prove this theorem. So we're going to show and justify why it works. So we're given our hypothesis here, given M is the midpoint of segment AB, we're going to prove that the measure of segment AB equals 1/2 the measure of AB, and the measure of MB equals 1/2 the measure of AB. So let's just start by drawing ourselves our segment here. So we have segment AB, and it gives us that M is the midpoint, so we're going to go ahead and draw that. Okay. So remember, our first statement is always the given. So M is the midpoint of segment AB. How do we know that information was given to us? And then our last statement is always what we are trying to prove, which with this one, I'm going to hold off on writing that because I'm going to show you it's going to look a little bit different with this one. So first thing, when you're looking at a proof, think about what you've been told. We've been told we have a midpoint. So keep in mind our if-then statements here. If we have this midpoint, then what do we know? What can we deduce? Well, the only thing we know is that we have a midpoint, and we do have a definition of a midpoint. We know that if we have a midpoint, then our segment gets split into two congruent segments. So that's really the only place to go from here, because you have to look at your given information. If I have a midpoint, then what do I know? Well, I know that that segment AM is congruent to segment MB. Right? Because if this is the midpoint, then I know either side is going to be congruent there. I knew that because if I have a midpoint, then I have congruent segments. So what was my reason? Definition of a midpoint. And I have a tendency to abbreviate definition, which you're also welcome to do. Have these equal parts. But if you look at your proof, we need to also talk about the full measure AB. So I have my segment here. This is going to be really similar to what we did before. I'm going to use my segment addition postulate to add up my parts. So I'm going to say that the measure of segment AM plus the measure of segment MB equals the full segment, which is the measure of AB, and I can do that with the segment addition postulate. Okay. So now I have my full segment set equal to AB, which is good. This is starting to look like what we need. I have my measure of AM right on the left. I have my measure of AB on the right. Same thing with a measure of MB, except if you look, these are separate equations. So I need to figure out a way to separate this and get the 1/2, right? So I'm trying to show that the measure of AM is half of the whole thing. So I want to get rid of MB and then vice versa. And I know that the measures are equal, so what I can actually do here is substitute one in for the other. So instead of saying AM plus MB, since I know here that AM is equal to the measure of MB, I'm actually going to replace AM, or I'm sorry, I'm going to replace MB with AM. So what I'm going to rewrite this as is the measure of AM plus the measure of AM equals the measure of AB. Because again, I knew these are equivalent, so I could replace this. And I'm actually going to scoot that over here because we are going to do something else in this step too that I almost forgot about. It doesn't want to let me draw on this side of my tablet for some reason. So I'm just going to write smaller in the middle. We'll see what happens. So AM plus AM equals AB. Okay, that's substitution. Okay, now if I have AM and AM, right, again, I'm trying to get my 1/2 here. What I'm actually going to do is combine my like terms and turn that into 2 times the measure of AM equals AB. And I can do that in the same step here because that's also the substitution property. I am replacing the measure of AM plus the measure of AM with the measure of 2AM because those are equivalent values. They mean the same thing. And I'm sorry my handwriting is so sloppy. My tablet is being incredibly glitchy today. So now what I can do, if you look, I'm almost there, right? I have 2AM equals measure of AB, super similar to this, except I need to take this 2 and get it to the other side and turn it into a 1/2. Well, you can do that by dividing both sides by 2, which is the division property. So I'm going to say that the measure of AM equals 1/2 the measure of AB. Again, I divided both sides by 2, so that is the division property. So now I have part of my proof. The only part we're missing is this. Now again, remember, those measures are equivalent. So I can technically now say the same thing about the measure of AM, or I'm sorry, about the measure of MB, because it's equivalent to AM. So if I can say it about AM, I can also say it about the measure of MB because they are equivalent values. So that's also technically substitution. So that is proving our midpoint theorem. Now let's look at the angle bisector theorem. That says if ray BX is the bisector of angle ABC, then the measure of ABX equals 1/2 the measure of ABC, and the measure of angle XBC equals 1/2 the measure of angle ABC. Now this picture down here does not go with that theorem. That goes with the proof below. So I just want to show you real quick what this theorem is saying. So if you have, I'm going to draw it off to the side here, we have angle A, B, C. And it has ray BX as a bisector, right? And if that's a bisector, remember it's going to split your segment or your angle into 2 congruent parts. So what this theorem is saying is that the measure of angle ABX will be half of the whole, and the measure of angle XBC will also be half of the whole. So very similar to the midpoint theorem, just with angles. So we're actually not going to do that proof because I'm going to have you guys try it out for homework because it's almost the exact same. Look at this proof here where we're given that ray EG is the bisector of angle DEF, which we can see here, Ray SW is the bisector of angle RST, and the measure of angle DEG is equal to the measure of angle RSW. We're going to prove that the measure of angle DEF is equal to the measure of angle RST. So those are the whole angles there. So first, let's write down our given. So we are given that ray EG, I'm going to abbreviate here and say bisects angle DEF, just to save some space. Ray SW bisects angle RST, and the measure of angle DEG is equal to the measure of angle RSW. That is given, and we are going to prove that the measure of angle DEF equals the measure of angle RST. So first thing here, we're told we have an angle bisector, and we have a definition of an angle bisector, which says we have, if there is an angle bisector, then there's two congruent angles. But now we also have an angle bisector theorem, which says if a ray is the bisector of an angle, then the measure of angle ABX is half of the whole, and the measure of angle XBC is also half of the whole. So we're actually going to apply this theorem here. And so how we're going to write that, and I'm actually going to write this in 2 steps here, just because I'm having issues writing with this stylus today. So what we can say is, since EG, ray EG is the bisector, we're going to say that the measure of angle DEG is half of the whole. That's where we're going to start. So the measure of angle DEG equals 1/2 equals 1/2 the measure of angle DEF. And then we can also do the same thing for the other side. So we're also then going to say the measure of angle RSW equals 1/2 the measure of angle RST. And we could say that because of the angle bisector theorem, and that's for both. It's like 1/2 of my tablet is working fine, and the other half is having some sort of fit today, so I apologize. So now what was the point of doing that? Well, we needed to find a way to introduce angle DEF and angle RST into your proofs, right? And we know these angles here that were marked as congruent are half of the whole. Or I'm sorry, that their measures were equal. We weren't told they were congruent. We were told their measures are equal, right? And we know they're half of the whole. So that gave me a way to mention the whole proof, or the whole angle in my proof. And now if you look, we know the measure of angle DEG equals the measure of angle RSW, right? We know these are equivalent measurements. So if those are equivalent measurements, then we can set 1/2 the measure of angle DEF equal to 1/2 the measure of angle RST. And what lets me do that is the substitution property. Again, I know the other measures were equivalent, so those are also equivalent. And then if you take a look, right, we're almost where we need to go. We just need to get rid of these halves. And if you could actually do this in one of two ways. You could think of it as you're multiplying both sides by 1/2. So you would divide both sides by 1/2. That would work. Or you could also multiply both sides by the reciprocal, which is 2. So this you could actually use multiplication or division property, just depending on what you're more comfortable with. I prefer multiplying by the reciprocal. So I'm going to say I multiplied both sides by 2. So that is the multiplication property. Okay. And then, so that's it for chapter 2-3, proving theorems. So in the next video, we're going to go on to the next page and look at section 4.